Greetings and welcome, friends, mathematicians, number fans of all ages. Turns out we're going over stuff for a test. It says 10 is at least, okay, so when I hear 10, that's what I imagine when I hear the number 10, is at least, that means it could be bigger, but it could be equal to it. The product of a number h, so product means I'm multiplying, h and 5. Which I'm a fan of writing the 5 before the h, but the way they phrased it, I'll leave it like that. All right, let's solve the inequality. Now, in this case, you could solve this in multiple steps, I suppose, but my strategy in the past is to multiply by the reciprocal, right? So I'll multiply both sides by -4/3 and -4/3. All right, settle down there with the crinkles. Watch what happens. The 3's swipe, swipe, 4 swipe, swipe, minus signs, swiper, swiper, and oh, these 3's over here as well. And I'm going to get n is now by itself, which was my goal. But I multiplied by a negative, so remember you got to flip the inequality, and it looks like n is greater than or equal to -4. Is my answer. Graphically speaking, and remember our graphs were super simple, 0, -4, just kind of put the points of interest. 0 is one of them that I'd want to see. This is a closed circle because it includes the equal part, and greater than would be to the right. Am I right? I'm right, friends. I'm right. I'm right. Okay, let's keep cruising. All right, this one's a little trickier. Let's see. So I've got variables on both sides. I'll bring the n's together. I'll add 3 into both sides this time. Why not? You could have subtracted n, and that would have been fine as well. 7 is less than or equal to 4n. 1n plus 3n is 4n plus 3. And now when I get the n by itself, two things are happening to it. It's being multiplied by a number and added by a number. We do inverse operations in the reverse PEMDAS order. So I'm going to deal with that 3 first, and the inverse of adding 3 is subtracting. Right, so yeah, you guys can just absorb this knowledge. Oh, settle down, settle down. Div 4, I get 1 is less than or equal to n, but let's flip this around, Ethan. I'll rewrite that as n is greater than or equal to 1. When I do the full flip, the sign flips with it. That would have been a closed circle that 1 shaded to the right. I'm not going to take the time to graph all of those. Here we go. This one looks like we simplify first, do some distributing. Whip, 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 whip. That's the sound effect that it makes, by the way. Official international math sound effects. And we got 3r minus 18. Bring these r's together, but friend, subtract 3, subtract 3. I get -8 is greater than -18. All my variables disappeared, but I'm getting a thumbs up because this is a true statement. Right? Right, Amity? Yep, that's a true statement, and that means there are infinitely many solutions. Oh, horrendous. Hooray. Okay, and by the way, the equation graphed out would just be a solid number line. It would just be everything. Everything works. Right? How crazy is that the graph is just todo de L points. Let's see. Let's keep going. Do I have one more? I'm doing pretty good. I'm on a roll. You guys are learning so fast. Okay. Remember this? Sometimes we had compound inequalities in which we had like, this would be an AND problem where our variable is in between two numbers. To solve this, normally I would have just subtracted 1 from both sides, but there are 3 sides today, so I'm going to subtract 1 from all 3 sides. Seems only fair that it is equitable. So 18 is greater than or equal to 3z is greater than or equal to a -6. Let's divide. I would divide by 3 to get z by itself, and we're going to do that to all 3 sides. So I get 6 greater than or equal to z is Nope. Greater than, man, come on, Mr. Waddy. Greater than or equal to -2. Let's write this from least to greatest, flipping the entire thing. So that's going to be -2 is less than or equal to z is less than or equal to 6. So this is an and problem. We had some questions about how to graph these. You basically target the points of interest, right? The -2 and the 6 here. Let me do this here. Let's see. 0, 6 would be like here. -2 would be closer to 0. This would be a solid dot at -2, Amity, and a solid dot at 6. And notice the z is in between those numbers, and my solutions that represent z will be in between those nombres. So that's what the graph would look like. Everything in between. And is together, and or is shaded away if you were to graph an or problem. Thanks for watching, Internet friends. Adios.